we now discuss the solution of a problem on the domain of a function, and it is from the section sets, relations and functions and trigonometric functions. And this question has appeared in joint entrance examination main held on 24th June 2022 in the shift 1. The problem is the domain of the function f of x is equal to cos inverse of x square minus 5x plus 6 by x square minus 9 upon by logarithm to the base e of x square minus 3x plus 2 is. We are given 4 options. Option A, the open interval minus infinity to 1. Option B, the open interval 2 to infinity. Option C, the interval minus 1 by 2 to 1 and closed at minus 1 by 2 end, union open interval 2 to infinity. Option D, the interval minus 1 by 2 to 1 closed at the minus 1 by 2 end, union the open interval 2 to infinity minus the set consisting of two elements 3 plus root 5 by 2 and 3 minus root 5 by 2. So we want to find the domain of this function, and the answer for this question is one among the following sets, and we have to determine which one is the correct option. We now continue the solution of this problem in detail. We have the given function f of x, and we want to find the domain of this function. The domain of f of x is equal to domain d1 intersection domain d2, where d1 is the domain of the numerator cos inverse of x square minus 5x plus 6 by x square minus 9, and d2 is the domain of the denominator, that is logarithm to the base e of x square minus 3x plus 2. Now we first find what is d1. The domain d1 is the domain of the numerator, and that is the set of all those real numbers x such that minus 1 less than or equal to x square minus 5x plus 6 by x square minus 9 is less than or equal to 1. Why? Because the domain for cos inverse is the closed and bounded interval minus 1, 2 plus 1. Now it is equal to the set of all those elements real numbers x such that minus 1 less than or equal to x minus 2 by x plus 3 less than or equal to 1. We notice that the numerator is x minus 2 into x minus 3, by the denominator is x minus 3 into x plus 3. We are cancelling x minus 3, both numerator and denominator. We can do so. Why? Because x minus 3 is not 0 in this interval. Minus 1 to plus 1, closed and bounded interval minus 1 to plus 1. In that, x minus 3 is not 0, therefore we can cancel off. Now this is further written as d11 intersection d12, where d11 is the set of all x belongs to R such that minus 1 less than or equal to x minus 2 by x plus 3, this part, and d12 is the other part. d12 is the set of all x belongs to R, x minus 2 by x plus 3 less than or equal to 1. So this interval minus 1 to plus 1 is broken into two pieces, and one is d11 and the other is d12. We continue in the next slide. And now d11 is the set of all those x belongs to R less such that minus 1 less than or equal to x minus 2 by x plus 3, and send minus 1 to the other side and write it in a greater than or equal to inequality. That is, the set of all x belongs to R, x minus 2 by x plus 3 plus 1 is greater than or equal to 0. And we have studied, and so now this plus 1 is added, x minus 2 plus x plus 3, that is 2x plus 1 by x plus 3 greater than or equal to 0. We have studied the inequalities and the domains, the corresponding domains in our earlier classes. 2x plus 1 by x plus 3 greater than or equal to 0 is equal to the open interval minus infinity to minus 3, and minus 3 is not included. Why? Because it is sitting in the denominator. And 2x plus 1 greater than or equal to 0 will be x is equal to minus 1 by 2, and minus 1 by 2 to infinity closed at minus 1 by 2, and because it is greater than or equal to also it takes. So that is the D11, and we continue and we will find D12 now. So D11 we have already calculated, and that is this one. And D12, we will go for D12. D12 is the set of all x belongs to R, x minus 2 by x plus 3 less than or equal to 1. Then bring that 1 to the left hand side. We'll get x minus 2 by x plus 3 minus 1. Simplify. We'll get the set of all x belongs to R such that minus 5 by x plus 3 is less than or equal to 0. Now we cancel off minus 5. Then the inequality is get reversed, and that will be 1 by x plus 3 greater than or equal to 0. So x cannot be minus 3 because it is sitting in the denominator. Therefore, it will be minus 3 to infinity. Minus 3 to infinity. That is the open interval minus 3 to infinity. That is D12. Now, D1 is equal to D11 intersection D12. That is, this is D1 intersection D12 is this, and if you intersect minus infinity to minus 3 and minus 3 to infinity, it is empty set because they are disjoint. And you observe that minus half to infinity will, and intersection minus 3 to infinity, and if you take the intersection, and this is this will be a bigger one, and minus 3 to infinity, and this will be minus infinity to 0. So this will be a smaller one, right? And minus 3 to infinity is a big one. So minus half to infinity is contained in this. Therefore, the intersection is this. Agreed. If you want clarity, you now draw the real numbered line and draw the respective intervals and see what is the intersection. So D1, that is the domain of the numerator we have found. Now let's get into the domain of the denominator. D2 is equal to domain of the logarithm to the base e of x square minus 3x plus 2, and it will be x square minus 3x plus 2 must be not equal to 0 and should not be equal to 1 because it is sitting in the denominator. If it becomes 1, and log 1 to the base e will be 0, and in the denominator if you have 0 and division by 0 is undefined, therefore that's avoided. So it is the set of all x belongs to R such that x square minus 3x plus 2 is greater than 0, but x square minus 3x plus 2 not equal to 1. And factorize this. That is the set of all x belongs to R, x minus 1 into x minus 2 greater than 0, and it is not equal to, therefore we have written then the minus set of all x belongs to R, x square minus 3x plus 2 is equal to 1. is equal to 1, and we have been made a minus. Other than these points, so this is x minus 1 into x minus 2 greater than 0, and that will be minus infinity to 1 and 2 to infinity. And these inequalities, I am sure you have studied in your earlier classes. So x minus a into x minus b greater than 0, then what will be the union of the intervals? And minus the set of all those x belongs to R, x square minus 3x plus 1 is equal to 0. This is a quadratic equation. It will give you two values, and those two values will be minus b plus or minus b square minus 4ac by 2a, and they will be 3 plus root 5 by 2 and 3 minus root 5 by 2 minus. So these are the roots of this quadratic equation, and this is as it is. And certainly these 2 points are in here, and 3 plus root 5 by 2 will be in 2 to infinity, because it is 3 plus more than 2, that is 5 by 2, that is more than 2. So that is, this will lie here, and this is less than 1, and it will lie here. Certainly these 2 points are in this union. Agreed. Now we have already calculated d1. It is the minus half to infinity, the interval, and closed at minus half end. The domain of fx is d1 intersection d2. The domain of the numerator intersection the domain of the denominator. And domain of d1 is this one, we have written here. d2 is this one, we have written here. Now take the intersection. I will show you the intersection. The intersection with the first, this is the intersection with the second, minus the intersection with this set consisting of 2 points. Now minus half to infinity intersection minus infinity to 1, and it will have minus half to 1 only, closed at minus half end. So that is, and minus half to infinity, 2 to infinity. If you take the intersection, the smaller of these two is 2 to infinity. Yeah, 2 to infinity is contained in this. Therefore, the intersection is 2 to infinity. And now, both these points lie in this one. So, therefore, the intersection is these 2 points. So, that is the domain of the given function fx. And if you see the options, our answer is exactly option D. Therefore, the answer to this question is option D. So that is the discussion of the solution of the problem that is given in one of these JEE examinations based on the domain of a function. But somebody has asked me, sir, this is a very big question. How do people do it? And one method, normally students will make some shortcuts, and it is not exactly a shortcut, but it's some kind of a guesswork. Now what they will do is this logarithm of x square minus 3x plus 2 to the base e lies in the denominator. Therefore, it should not be x square minus 3x plus 2 should not be equal to 1. That they will guess. And there should not be 1 means this is a quadratic, therefore it has 2 roots. These 2 roots are this. So therefore, your domain should not contain these 2 because this is sitting in the denominator. So these points are to be avoided. Now, if you go to option A, minus infinity to 1, in this 3 minus root 5 by 2 is there, but 3 plus root 5 by 2 is not there. So therefore, this is not the answer. So, because this is included, both these points are to be excluded. Now, if you go to the option B, 2 to infinity, in this 3 plus root 5 by 2 belongs to this, But whereas the second one, 3 minus root 5 by 2, does not belong to this. So therefore, that's not the case. That's not the case. And C contains both of them, but your answer should not have these 2 points. So therefore, C is also not the option. Therefore, these 2 points are excluded here. Therefore, and A, B, C are not the answers. Therefore, and these 2 points are not included here. Therefore, the option D is the correct option. That's how students will eliminate this one. This is the elimination, the method of elimination for getting the correct option. So that is the discussion of the solution of this problem based on the domain of a given function. And I am sure that you have understood the solution of this problem. And I wish you all the best. Thank you.